Well, hello friends. Welcome back to the program. Today we are going to take a look at UBSAN, or the Undefined Behavior SANitizer, and try to integrate that into the Serenity OS kernel. So UBSAN is a compiler feature of both GCC and Clang that allows you to compile into your app instrumentation that detects undefined behavior at runtime, and then spits out a warning if you do something like integer overflow, or you bind a reference to a null pointer or something like that. So it's very, very useful, and we already use it today on our automatic fuzzing setup. But would like to also be able to build our kernel with UBSAN, and then use that to catch UB problems. So today we are just gonna jump right into this by adding a flag here. So something like this, sanitize undefined, and then we will just deal with whatever comes next. So I think when you're using UBSAN in user space, then the compiler provides some kind of library that does the diagnostic output for you. So it will print out like a little message and stack trace and stuff. But in a kernel context, the compiler doesn't know what we want. So I think we have to implement our own callbacks, basically, and then like decide if we want to panic the kernel or just print a message and move on. And as you can see, there's a billion link errors now because UBSAN is trying to call its handlers. So you got stuff like UBSAN handled pointer overflow, handle type mismatch, whatever else. I feel like I'm seeing a lot of those too, but I'm sure there are other kinds. Anyway, there's like way too many here to deal with, so I think the undefined option is a combination of many options that you can select from. So right, so it's like a combination of these sub options. So let's just pick like one or two of these so that we have a reasonable set of linking errors to start with. So we can pick something like I don't know, like non-null attribute maybe, and bool, instrumentation of loads from bool. If value other than 0 or 1 is loaded, a runtime error is issued. Right, so that's a nice little option. Yeah, let's do those two. Sanitize. Bool, so like that. And then we'll have to rebuild, but we should only have UBSAN emitting calls to these two handlers, which we then have to implement. So we have handle load invalid value and handle non-null arg. And it's just those two over and over. So I think we can handle that. And let's make a function to deal with this. So like UBSAN CPP. Or should we call it, I mean, we don't have to save space here. We can call it, getting really important here, SANitizer. No? Okay, much nicer. Fresh. Okay, and let's also add it to the build system. Okay. So, what do we need to implement in here? We need this thing and non-null arg. Right. So, and then we need to figure out what kind of arguments these get and stuff. But this should be a start. Okay, and then we'll just grab the usual stuff. So like, yeah, does that compile if we just do that? No previous declaration. Oh, right, yeah, right, because we have that warning. So, you know what? We can even do something like this. Because why not? Okay. Oh, almost okay. And that compiles. Cool. Does it run, I wonder? Let's find out. Okay, compiles, runs. Nothing bad happens. That's good. So let's like assert that we don't reach these. And then see if we have any hits right away. Seems like we do. Okay. Well, that was really fast. Okay. So on line 15, we're hitting this one right here, handle non-null arc. And it's so early in the boot that we haven't loaded symbols yet. But we do have addresses, so we can figure out what this is. Let's just use adder to line. CPU.cpp 2271. Yeah, that's the assertion failed. Sure. So the next frame was user or kernel buffer 33. That's an uninteresting stack frame. So what's the next one? Typed transfer 56. So it's a call to mem move. So presumably we are passing a null pointer to mem move then, which I suppose we shouldn't be doing. So wait, who's calling this? CPU, CPP, 1107. Processors resize. Okay, so we create a processor vector and then we resize it to some number. So, oh, I get it. Okay, so it's like we have an empty vector and then we're trying to copy 0 elements to the new storage. But if count is 0, then the source will be a null pointer because there's nothing there. It's just that then we probably shouldn't be calling memmove in the first place. So I think the fix here is just to say if count is 0, just return 0 because we return count everywhere. And then we have kind of the same issue repeating elsewhere here. So if not count, return true, I guess, because that's where we would naturally end up. And likewise up here. So, okay. Cool. I guess that'll take a moment to build because this is included by everybody. But that seems like a sensible fix. Like we shouldn't be calling memmove with a null pointer. So excellent discovery. Let's see once the build finishes what we can run this. Okay, let's try again. See if we hit anything else. All right. Uh-huh. Handle load invalid value. So where are we now? We are in... Okay, so I feel like these functions, they get more metadata. It's just that I don't know what it is. So let's figure that out first, because like this kind of stack, I don't want to I don't want to sit here and add or to line everything. So let's see what GCC is actually generating for this stuff. So if we look at our tool chain, and then we just look for this thing. So it's in libSANitizer, UBSAN handlers. That's called handle load invalid value. Okay. And then it gets some invalid value data. So I assume that this thing is like the same thing. This is like the library thing that you would get in user space. I think this is that. So we can accept these two arguments as well. So let's just try to do that. So let's figure out what these types are. So libSANitizer. Okay. Oh, so it's right here. Okay. So invalid value data. Well, that looks straightforward. So, okay. So a struct invalid value data has a source location and a type descriptor. Sure. And what are those? It's not defined here. Cool. What's a type descriptor? Also not defined here. Fine. Source location. That's in UBSAN value. All right. Okay, so that's type descriptor and source location. Okay, so these are some classes here, but the functions are just helpers. So the data layout is going to be like this, I think. So we can probably just do like, maybe we should put this in its own little namespace here. UBSANitizer. Okay, and why don't we put one of these little puppers just in case. Okay, so the important stuff is that we just need to know the data layout, and then we can make up our own things. So we need a file name and a line number and a column. Okay, and then what else did we have? We had type descriptor. Okay, so type descriptor is a type kind, a type info, a type name, and the kind is some enum, whatever. Okay. So type descriptor, and what was it now? Type kind, info, and type name. So let's call it like M name. And then did it have any more members? No. Okay, and then kind. Type kind is U16. It's either an integer, 0, float 1, or unknown. So integer, float, and float is irrelevant in the kernel because we don't allow floating point in our kernel, like that won't even compile. So they're all going to be integers. But that seems fine to keep the data structure. Okay. So do we want to have like a nice little interface here? So, oh wait, what was the other value that we had? Value handle. What's a value handle? It's an opaque handle. Okay. All right. So it's just like a void star. Okay. Well, I think we have enough. So let's see. Let's just make our own little helper functions here. So const return and then file name. Fine. That's gonna make this look real nice and Serenity-like. Okay, and for type descriptor, we'll have, I think, like type kind. Kind. And what was the info? Wait, I forgot what that was. A type-specific value providing information. So what is that used for? So if it's an integer, then it's assigned or unsigned information. And then the bit width is in there as well. Okay. And then for floats, we don't care about floats. Okay, so it has the signed, whether it's a signed or unsigned type, and it also tells us the bit width. That's cool. So we can work that out as well. So we can even say something like is integer that was determined by the kind. So kind is type kind integer, and then the is signed is info and 1, right? Yes. Oh wait, I'm not in Vim. I thought it was in Vim. Unsigned is like, oh, that's just the inverse of is signed. Okay. And then the bit width is how is that stored? Oh, it's just like that. Okay. So okay. And oh, the name of the type, of course. So name. Cool. So those are our things, and then here we had, oh, this is for the non-null. For invalid ones, we have in UV SANitizer. Should probably put it in like its own little thing here. So kernel UV SANitizer. Invalid value data. Or maybe we'll even do this using namespace kernel UV SANitizer. Data and the value thing. So I'm not sure what to do with that value thing. So we'll just do something like this. And I'm assuming that it's okay to take that as a reference, right? Data, but will that ever be null? Handle load invalid. I mean, look here, like they dereference it right away, so it's probably okay to just take a reference. Okay, so let's see what we can print from this thing now. first let's do a backtrace. So we will like dump backtrace. Yeah, so this is a little unusual for me, but I'm just doing this because we are doing C functions, although, yeah, that's a little unusual. So let's see, let's dump a backtrace, and then I guess we can keep going even though you do this, right? So we just want to print a message here. Like debug line KUBSAN says invalid value, load invalid value. Yeah. And then reload data type name. What else did we have? Bit width. Okay, let's just see what we can get out of it if we show with bit width. Something like that. Okay. I mean, I'm not really sure what we're gonna get, but so did we get something? Okay, so we got load invalid value bool with bit width, and then I forgot to put those. Okay. Load invalid value bool with this bit width. Yeah, so I mean, this is too early. We don't have symbols, but at least we know it's a bool. And we do have that source location thing, so we can actually print that as well. So let's say like bit at file colon line column, something like that, right? So data location file name, data location line, and data location column. Okay, this is really cool. So we have a load invalid value. We're loading a bool, 8-bit, at shared IRQ handler, line 115, column 10. Shared IRQ handler, CPP. Line 115. So we're loading this bool, and it is invalid, I guess because it's not initialized. Looky look, it's an uninitialized member variable. Come on, we shouldn't have those. So let's just initialize it. And does that make it go away? Wait, what? Now we're crashing during boot instead? Wait, were we relying on this thing being enabled by accident? Because if so, come on. Ah, I guess we were. Okay, well, that's really stupid. Yeah, that's so dumb. So the constructor doesn't set it. Just disable interrupt vector, which checks if it's enabled. Okay, so we found a real bug. That's fantastic. I guess 2 bugs, both that memmove thing felt like a little, like, oh, it was probably working right anyway, but we should fix things like this. Okay, so let's just clean up after ourselves here. Although, for that first issue, let's undo that change and try to make a nice diagnostic. So UBSAN, because handle non-null arg, I guess takes or gets you like a different set of things. So non-null arg gives you non-null arg data. Non-null arg data. Okay. Source location, attr location, and argument index. Okay, so this is pretty straightforward still. So now we get like a non-null arg datum. And what was it? An int argument index. Yeah, so I guess it's the location of the attribute. So since they call it attr lock. So let's see what we can print about that then. So this one gets a non-null arg data. So non-null argument oh wait, they have some like, we can even use like their phrasing here if we wanted to, like null pointer passes argument which is declared to never be null. That's pretty neat. So null pointer passed as argument with index, which is declared to never be null. And maybe we should have like a separate line with the location info. So we can do that like, first we'll do the argument index here, and we can make a helper that just dumps out the location. Print location. So do we have new debug, or what do we call that thing? I forget. We got rid of that guy. Did we not add a debug? There's only debug line. Okay. I just wanted to do one without doing a line break, but I guess this is fine. So debug line, KUBSAN, and we'll just say like at file name, line, column. Cool. And that's fine. And then we'll do the same thing here. So we'll just drop all of this gunk. Print location, data, location. Yeah, because then you can like work out the rest yourself. So what did they say for load invalid value? Handle load invalid value. Load of value, which is not a valid value for type. Oh, interesting. Wait, so they tell you, they print out what the value is. I assume that they do some trickery to, like, based on the type information, they know how to print a thing. How do they do that? Value. Class value. A value handle. Okay, well, that's, we don't have to do all that right now. Like, pretty printing the actual value that was, like, misloaded, we can do that later, but right now I just wanna like, get this working. Holy moly. Oh, right, now, so we get a lot of these, like, null pointer passed as argument 2, which is declared to never be null. KUBSAN. So this is really neat, actually, because now, see, you can see, like, the backtrace and everything. Very, very cool. And oh, that's so cool. I'm just, I'm really happy with this. So let's see. Let's put that patch back. So build saved. So that we don't get that extreme spam. And that Boolean load issue was pretty stupid. So it's a good thing that we found that. And yeah, we're definitely not going to do all of the ones today, but we'll do, we can add maybe 1 or 2 more. So we are up and running. No complaints. Very, very cool. Okay. I think let's maybe commit some fixes here. So kernel, add missing initializer for shared hierarchy handler and enable. Found by KUBSAN. KUBSAN. And maybe we should add KUBSAN first. Let's see. This should be optional. Or, I mean, it doesn't feel heavy at all. So maybe we'll make it always on for now, and then if we add more options and it turns into a slugfest, then we can rethink that. But like right now, this seems perfectly snappy and normal. So I would rather have it on so that if people encounter something that they can see it and report it. So I think we'll leave it on for now. We'll come back to that, probably have to reevaluate as we add more options. But that's really sweet. So let's add it. Kernel. Build with KUBSAN. Kernel undefined behavior SANitizer. We now build the kernel with fsanitize some KUBSAN, partial KUBSAN support, fsanitize non-null, the following fsanitize options are sub options are enabled. What are they called? Non-null, no, I already forgot. Non-null attribute and bool. If UB is, if the kernel detects UB at runtime, it will now print a debug message with a stack trace. This is very cool. I'm leaving it on by default for now, but we'll probably have to reevaluate this as more options are enabled and slowdown increases. Still, that is very, very cool. So then we'll also put that fix into ACK. So ACK fix avoid UB in typed transfer. Don't be calling built-in memfoo with null pointer arguments. Found by KUBSAN. Okay, that's really neat, but let's just reorganize so KUBSAN comes in first. Okay, and then let's try enabling some other option. So what else? So we got shifts, integer divide by 0, VLA bound, instructs the compiler to check that the size of a variable length array is positive. Well, that's a weird one. You would have like a negative sized variable length array. I mean, if we have that, that is a strange problem. Signed integer overflow. I definitely want that one. So I guess let's do VLA bound and signed integer overflow. So VLA bound and signed integer overflow. Okay, so let's do these two, and then that can be it for today. So I'm guessing these are going to be called handle. Oh, this is taking too long. Handle signed integer overflow, perhaps? Handle sub overflow add overflow. Sure. And what arguments, pray tell, do you receive? You, of course, get overflow data. Cool. And that, of course, is a source location and a type. That's easy enough. So, struct overflow data, source location, and a const type descriptor. Very, very basic. Yeah, so they just get overflow data and the value handle, oh, the left-hand side and the right-hand side. Okay, but we don't care about the values right now. We just need to know where this is happening, and then we can go there and figure out the rest when this comes up. So we'll say void something like that maybe. And here, we're not going to use them right now, so just as a note to our future self so we know what those things are. So these are add overflow, and then we had sub overflow, and then we have live overflow, and what else? Negate overflow. I assume negate does not have a right-hand side, so yeah, just a value. Sure. Mul overflow and VLA bound not positive. Okay, we're getting there. And you get a VLA bound data and a value handle. Cool. And also I feel like these could just be const because we're not doing anything to these boys. I suppose if you wanted to like annotate that, like, oh, we've emitted a warning at this location before, so we don't need to print it again and again and again. That's something that we could sort of store. You could like overwrite the thing with a marker that says like, oh, you don't need to print this again or something like that. I don't know. But let's not care about that right now. So we had mul as well. Mul, on the other hand, does have a left and right side, usually. VLA bound data, what are you? Source location and type, of course. What was I expecting? Cool. So first, let's just do this to see which one we hit. Which one we hit first. It's kind of funny that like we keep hitting them, hitting whatever we add, we just hit. So it seems like it's about time we do this. Okay. We're hitting sub overflow as our first hit. Fantastic. So we have sub overflow somewhere. I guess let's print something then. Man, we should have done this sooner. Subtraction overflow. And type maybe, and how many bits? Wait, overflow data doesn't have two types. Did we only get one type for that? Overflow data. I guess I assumed that we would be able to see both sides of the operation, but I guess not. Still, that's okay. So here, let's just print out like data type name and data type bit width, and then print location, data location, and then maybe let's just hang this this thing so we can see where we are. Subtraction overflow in random.h 113.33. Wait, subtraction overflow. What are we even subtracting? If reseed number modulo 1 shifted left I times, and how high do you go? So we're shifting this guy 32 steps. Wait, is that undefined behavior to go shift 1 32 steps to the left? Sub overflow. Wait. Now I'm just gonna guess here, because okay, so that was indeed the issue. I don't know why that turned into a subtraction overflow. I guess the compiler turned this into a subtraction somehow, but we can't be shifting 32 steps to the left, because we'll run out of bits. So and then we hit a VLA bound not positive. Dude, what the frick? Okay, so we have a negative sized variable length array in the ext2fs code. What the heck? All right. Block list for inode impl. Let's just go take a look. But oh, I guess we can print out exactly where it is. So we just need to. This one is the weirdest, because like, what the hell is negative sized variable length array look like? What was it called? VLA bound not positive. And it has a type, so I guess we can print out the type. That's fine, and then we'll print a location, data location, and then let's just halt the world so we can see what this is. Print location. I feel like, oh, maybe print location should do a backtrace, because then we don't have to do that after each one. ext2 file system line 503. Right. Okay. So it's this guy right here. So this is somehow giving us a negative number. Let's just print out the number. The minimum of number of blocks remaining and entries per block. So this one would not be negative. So we would have a negative number of blocks remaining. Or 0. Okay. All right. So 0 is considered not positive. Fine, I guess. But so it's not negative, it's just 0. Still, we shouldn't be here with a 0 length VLA. So what is this even doing? So process block array. So we are generating a block list for a given inode, walking the direct, indirect, doubly indirect, and so on block lists. And we're making a VLA, and we don't have any blocks remaining, so we shouldn't even be here. So I guess if we shouldn't even be here, there's nothing left to do, because we've processed all of the blocks, so we just gotta leave, I think. I think that's fine. We can just leave. We have all the blocks, dude. It's a little bit weird, but I think it's probably okay. Okay, we're up and running. Stuff is alive and works. Floop. Floop, floop, floop. Let's go to the web. We are on the web. All right, we have browsed to the internet. Okay, I think we're still good. So those were some weird bugs. But now we are in a good place, it seems like. So let's run the JavaScript test suite, see if that finds anything. Nope. Okay. Cool. So I think let's commit these new KUBSAN modes. Oh, wait. I didn't print anything for these other ones. Also, let's not halt when this happens. Let's just note that it does. Because I guess we can carry on. Should we halt when this happens? Part of me wants to panic the kernel when any of these happen, just to turn it into an issue, make people report it. But we can also just carry on. Let's just carry on for now. So addition overflow. Negate overflow and multiplication overflow. Negation. Yeah. That's good. Okay, so we're adding a couple of more modes here. So we were adding VLA bound and signed integer overflow. And 2 more KUBSAN checks. It's following KUBSAN SANitizer, undefined behavior SANitizer sub options. Yeah. Okay. And then we found issues with both, so that's cool. Don't create a 0 length VLA in ext2fs. Block list walker. Found by KUBSAN. Yeah. Don't shift 1 32 to the left 32 times. Found by KUBSAN. Sure. Okay, so I think that's enough for now, because I'm running a little low on time, and we got some good loot here, so very cool, good progress. If you made it this far, then I thank you for watching and for hanging out. I hope that you saw something interesting. I think based on how many issues we already found, this is a very good idea. Not completely sure that we're going to leave it always on, but right now it seems very reasonable to leave it on because we're probably going to find more issues just by running it and messing around with stuff. So very cool. Yeah, I guess I hope you saw the value in this, and thank you for hanging out. And what do I normally say? I guess I'll see you next time. Bye.